Okay, so how this lab works, what we would have done normally if, there wasn't a virus desperately trying to kill everyone, you would have gone around the building with a tennis ball and dropped it from multiple heights. Now, the key word I said was drop, which implies that you just release it, so its starting velocity is 0. The acceleration should be negative 9.81. And the purpose of this lab is to confirm, is it 9.81? So you would drop it from one height. So you set height, and then you record time. Okay? And from a couple of different heights, you would drop it, and then you would record the time. And you would use that data to see, well, is the acceleration actually 9.81? So you know V initial, you know delta y, you have time. You want to solve for A, which means you want this equation. We can simplify it because there's no initial velocity. Your delta y is your height. There you go. Now, the time is the dependent variable known as the y-axis. And the height is the independent variable for your x-axis. So as you graph it, you would want to graph t squared and h. So why t squared instead of t? Well, because the dependent variable is squared. So h doesn't correspond to t, h corresponds to t squared. Now here's the cool thing. We know slope is rise over run, right? So rise is t squared and run is h. Let's take a look at this equation here. H equals 1/2 at squared. All right. So 2h equals at squared. Let's divide out the a. 2 over a times h equals t squared. Let's divide out the h. 2 over a equals t squared over h. T squared over h, that's your slope, because that's rise over run. But guess what your slope equals? 2 over a. You plot your points, you get your line. The slope of this is 2 over a. What's the acceleration? Should be, negative 9.81. Now, are you going to get negative 9.81? No, it's an experiment. So what you can do, though, is you can see, well, what was the margin of error in this? That's how you're going to find out what was the experimental value for gravity. You're going to plot t squared versus h. You'll get a best fit line, and you'll set the slope of that best fit line to 2 over a. Solve for a. That tells you what was the acceleration due to gravity. You can't actually go and drop things. Well, you can, but you don't need to. I've created some data for you. What you do need to do is you need to modify the data and then make a graph. You're going to save it as a PDF, and then you'll submit it in here. There's 4 questions that go along with it. The questions here are previewed before you actually open up the submission file. Submission file asks you for names and hour, and then asks you to upload data table and graph and answer the 5 questions and submit. So the last thing I'm going to do for you is I will show you how to create that graph. First thing, we need the data. I can just copy and paste it right out of here. Copy. And paste. Let's clean it up, make it look pretty. I don't want time, I want time squared. So what I'm going to do, I'm going to put all these in the same font. And let's go size 12, center everything. Okay, cool. I could use a calculator to go 0.65 squared, type it in. 0.93 squared, type it in. 1.14 squared, type it in. That's fine. I can fly to Chicago by going east, but I'd rather go west. Instead, what I'm going to do is I'm going to hit enter. And all I want to do is I want to take this piece of data here. I click on it, caret 2. I want to square it. Hit enter, and there it is. Now, I don't want to type in that formula 4 more times. So I'm going to grab right here on the lower right corner and drag down. There it is. Just populated it all for me. That's my data table. Data tables deserve a title, so let's give it a title. Drop height, first time. Oh, make it pretty. Voila. Okay. Now we need a graph. So to do the graph, I want to graph height and time squared. The way I was able to grab the height and the time squared while doing it simultaneously is once I let go of the height, hold control, and I grab time squared. If you're on a Mac, I don't know how to help you. We're going to insert, chart. There it is. Now, maybe it gives you a scatter plot, maybe it doesn't. But right here in setup, under chart type, you can pick whichever you want. What you want for this class always is a scatter chart. If you're not happy with the axes labels, you can play around with those as well. And the customize chart axes or chart and axes titles, chart style, all these fun things. Now, what you do care about is right here in series. Under series, we're going to add in a trend line. This is the best fit line automatically calculated for you. You could calculate the slope, or you could have the computer do it for you. Under label, there's use equation, and now let's just spit out the equation of the graph for you. Take your graph, let's move it here. I don't need this window anymore. It looks nice and neat and pretty. I'll open up something like Paint or wherever else I can just dump files. I'm going to Windows Shift S at the same time. Select this, drop it into here. I will print. Microsoft Print to PDF. Print this. I need a name for it. I think something like gravity data is excellent. Yeah, I'll replace it. And then as I come back to this lab, I can go ahead and upload my file, gravity data, upload, and success. I can preview it too to make sure that it looks nice and neat how I want it, and certainly it does. Here's the best thing too. I already have my slope. I don't need to calculate it. The slope is 0.237. That's it. Done for me. Perfect. Afterwards, I can go through and answer the questions. What's the slope of the graph? 0.237? What was it? Yeah, 237. Okay. Slope in terms of variables, I already answered that for you. Experimental value due to gravity. You're pretty darn close to doing that. And percent error. To remind you, how do I do percent error? Percent error, what we will do is we're going to do the absolute value of the actual value of gravity minus your experimental value. Divide it all by the actual value. Take that whole thing, multiply it by 100%. And with that,